How many of you are Netflix members? Okay, there was no point to me asking that, I just wanted to know. So my name is Kelly, and I'm the Director of Experimentation and Algorithms for Growth and Targeting at Netflix, which is quite the title. And I'm part of the larger Science and Algorithms team, and we're the advanced analytics team that serves the entire company. So not only what my team does, but also all the production algorithms, like when you have your top 10 and you hate the recommendations, let me know, and I'll tell my colleague Antonio, because they're the ones that research all of those algorithms. So let me see if I can, right. So a little bit about me. I have the weirdest path to my current position ever. I started in the Peace Corps, and I was doing economic development. And then I worked at Geico, which is in Washington, D.C., and I was doing mostly predictive modeling, but also some other things. Then 3.5 years ago, I moved to California, and it was, my interview at Netflix was the first time I ever went to the state. And 3.5 years later, I managed a team. And then I borrowed these slides from a talk to a women's group, so I also, on the side, work for an organization that helps women in post-conflict countries get educational opportunities in the US. And so we're going to Cambodia next week, which I'm super excited about. Relevant because Netflix has a pretty cool culture, and you may have read that we do not have a vacation policy. There's no time cards, there's no you have your 3 weeks, it's whatever you want to take, and so that allows me to go to Cambodia for 2 weeks. So if you think about Netflix, there's 3 pieces to our company, 3 main pieces. And so there's content, so those are the super cool Hollywood people who are making all the deals. So if you've ever heard this guy Ted Sarandos talk, he's our chief content officer, and they're located in Beverly Hills. Then there's marketing, and so they're the people who are helping not only market our company, but also market our content. And then there's the product organization, which is all the front end, back end, facing parts of our company. It's the engineering function of Netflix. So what does my team do? We have 4 main analytic outputs that we provide the company. One is A/B testing, which I'll talk a little bit about today. But the second is a different type of experiment, and there's multiple types of experiments, called quasi-experiments, which is something we've been doing pretty heavily for the last 9 months, and we're super excited about it, and I'm going to talk about that today. The third thing is predictive models, and the fourth is algorithms that are in production. And we serve both product and marketing. So, you know, the Netflix culture is very important to consider with all of this sort of information that I'm going to give you. And we do, everyone says this, but we think we have a very unique culture. And the main pillar of our culture is freedom and responsibility, which means we hire fully formed adults and we treat them accordingly. And then all the other things that you'll see on this slide are super important because, you know, data can be used, I think, in 2 ways. One is as a democratizing force that gives everyone a voice and helps people make really good decisions. And then the second is it's a weapon that can be used to justify what someone already wanted to do. So if you don't have the right culture, I really think that, you know, data really cannot have the impact that you would hope it would have. So in terms of experimentation, this is, on the product side, the foundation of our entire innovation methodology. So 95% of our customer-facing decisions are made based off the results of A/B tests. So if there's something about Netflix that you don't like, it's unfortunate, but it's because most people, or more people than not, did like it because we A/B tested it. And so with all of our A/B tests, our core metric that we decide a win or a loss by is they're all revenue-based. And we test on essentially every person in the universe. So people who've canceled, people who haven't been members yet, people who are in their first 30 days, people who've been around for 12 years. We test on all of these cohorts. And we experiment in all areas. So things that might be really obvious are like what our UIs look like, what our algorithms are. But things that are not as obvious is what time of day we try to charge your credit card. Those are all A/B tested. And so when I talk about the product side, most of our experiments are run as A/B tests. And so I think most of you are familiar with what an A/B test is, but let me briefly just review it a little bit. So, and also I ran this presentation by one of our chief product people, and he was like, oh my God, don't show that example. They're gonna think that's the kind of thing we A/B test. This is from like 10 years ago, but it's just a straightforward example to get my point across. So let's say, you start with a hypothesis from the beginning. When you do an A/B test, you always wanna start with your hypothesis from the beginning, not we look at the data and then we decided what we want to learn or what we wanted to happen. So here our hypothesis is that, if we add this 1-month free trial badge to our landing page, conversion will increase. So what we do is we take our target population, which are non-members, and we randomly assign them into test and control groups. And then depending on the group that you're in, you get a specific Netflix experience. So because of the random assignment, we hold everything else constant. So that's gender and income, propensity to want to sign up for Netflix in the first place. And because all those other factors are held constant, when we go to analyze the results of the experiment after the fact, we know that any observed difference beyond what we would expect just from random chance has to be because of the variation in the Netflix experience itself. So it gives us that clean read on causality and incrementality. So you know that from those results, if I roll out that free trial badge, that I'm going to cause more people to sign up. However, there are many questions that cannot be A/B tested, and especially in the marketing space, because so many of the questions are outside of our control. And so here's an example of something that we think about is TV advertising. Like, how long is that going to be effective? And so what if we have the question, okay, what if we shut off TV advertising and we shift all of that budget into online videos, which is mostly YouTube and Facebook? So you can imagine how difficult this would be to A/B test, to randomly assign a user. Okay, you see a TV ad, you see a YouTube video. TV's not bought that way, and it's super hard to control things that way, so you just can't run an A/B test. But you still want to infer some sort of causal function, causal inference, so you can make a decision. So enter the quasi-experiment, which is another type of experiment, as is an A/B test. And so again, with an A/B test, it has certain characteristics like this random assignment, user getting specific treatment based on their assignment, a clean read on causality. The analysis is pretty straightforward. It's like a t-test or a z-test in most cases. But a quasi-experiment instead has what we call quasi-controls. And so it's not a perfect control, but for example, you can take two regions that are similar to one another. So that could be like, Sweden and Norway, or you take Mexico and you say, okay, Guadalajara and Monterrey. And I'll talk more about what I mean when I say similar in a couple slides. So the user isn't assigned to that group. They're in that group because they were already in the group, because they already live in Guadalajara or they already live in Monterrey. So despite all of our analytical rigor that we can apply to this, which is what I'm going to talk about, we'll never ever achieve that pure causality that we would with an A/B test. So what we aspire towards is a directional read, which is better than nothing, and we feel like we can get it to the point where it's good enough to make a decision from. So these are kind of some of the main lessons we've learned in the last 9 months, and we've failed many times. As the last speaker said, it's good to fail, and we have achieved that goal. And so I think the first thing is having a clear learning objective. These experiments are murky as it is, so just establishing up front what you want to learn is super important. The second thing is what can and cannot be learned. For example, if you run a quasi-experiment, yes, maybe you can learn that online video is more effective than TV, but are you going to be able to measure the effects within like 0.2 of a decimal point? No. And you just have to set expectations to the business. That's not going to happen. The third thing is really important, what can and cannot be held constant. So for example, if we were like, okay, what's more effective, outdoor media or digital? So you run that experiment and you look at the results. It's not just about outdoor media versus digital, it's also about, okay, how many impressions are in the marketplace? How much did you spend? Like outdoor media is typically, depending on the country, more expensive. So you have to think about those things. It doesn't mean you did anything wrong, it's just important for how you interpret the results and how you act on the results. And then the fourth thing is picking the right test and control regions. And we'll talk a little bit more about that. And then another important thing to consider is if you want to run this type of experiment, And I'm sure most of you sitting here can think of at least one business question that your company has where you can't run an A/B test, but you'd really like to know the answer. So one thing to think about is when you plan for this experiment and you say, okay, Guadalajara is going to get this type of advertising and Monterey is going to get this type of advertising, and then 6 months later you look at your results and they look weird, you go back to your media planners and they're like, oh, we forgot, oh yeah, they didn't quite get what they thought they were going to get, and the impression count was kind of not what we thought, and that invalidates the whole experiment. And then the last thing I'm going to talk about is you can do all these things and you can do them all well, but these groups are still going to be different. Like Sweden and Norway are not exactly the same type of people, and they're not going to react exactly the same way to some sort of experimental intervention, be that a different type of advertising or a different type of user interface. So you can deploy models to adjust your raw results based on how different they were historically. Okay, so I wanted to talk about how do you choose the right control regions. Before I do that, can I just see, is there anyone who has done any type of experimentation like this at their company? Okay, one guy, two, oh, good, okay. And how many people would be interested in doing something like this? Okay, hopefully by the end everyone will raise their hand. Okay, so choosing the right control regions. So when we say region, it's a very vague term, and we mean either DMA. So the United States is a very fertile ground for experimentation because there's 211 metropolitan areas called DMAs, so that's like Raleigh-Durham, Houston, et cetera. So imagine how much learning you could get just from the United States. But Netflix is all over the world, so we have more options, including cities. So in Mexico, there's a ton of cities. In Brazil, there's a ton of cities. In Germany, there's a ton of cities. And then countries. So there's some regions where there's countries that are very similar to one another. The Nordics, Sweden, Denmark, Finland, Norway are very similar to one another. And some of the Latin American countries are very similar to one another. So a lot of times when people have done this in the past with match market testing, they use factors like size, demographics, culture, and we don't do that because we actually don't think that's as accurate as what we do, which is we cluster them based on how similar they are in the outcome metric of interest. So if we want to measure the impact on total signups, we want to choose test and control groups that behave similarly over time in terms of that metric, because it's directly what we're trying to measure. And so what we look at is the shape of their time series. So signups over time, Raleigh-Durham versus Atlanta, are they similar? And so we use some clustering techniques, which many of you may be familiar with since this is predictive analytics, sparse k-means, or, it's so hard to say this, hierarchical agglomerative clustering. I had nightmares about saying this. And so those are two ways that you can cluster cities or DMAs together based on some sort of time series. And then once you have these clusters, like you take the 211 DMAs, maybe you end up with 7 clusters. Well, DMAs within those clusters, there's your test and control groups. And then also, we don't have a computer at Netflix that like spits out this and marketing takes it and like goes and does their thing. There's a little bit of business judgment. Like recently we were like, oh, Helena, Montana is such a good control for Seattle. And they were like, are you out of your mind? We are never going to buy local media in Helena, Montana. So we're like, oh, okay, well, you can use something else, Portland. Okay, so this is kind of an example of what it looks like when you cluster DMAs or cities based on their time series, based on some metric over time. So here we have 7 clusters. And so there's multiple DMAs within these clusters, and those are DMAs that are similar to one another. So if you're in cluster 1, maybe there's 13 DMAs in cluster 1, and they've been clustered that way because they have similar time series. And we don't, this given implementation of a particular algorithm doesn't cluster based on just the normal day-to-day variation. It really looks at how DMAs react to outlier events. So you'll see cities or DMAs in cluster 1 all have a very strong reaction in terms of a particular metric that I cannot mention to Black Friday. So they're clustered together. You can see that cluster 3 reacts similarly to the launch of Arrested Development, which was, used to be on Fox and now is one of our original titles. Season 4 was on Netflix. Cluster 6 had a very strong reaction to House of Cards. So this is particularly relevant to us because of a lot of our experimentation happens in the context of campaigns, which are around title launches and things like holidays. So you can parameterize the algorithms, the clustering techniques, to your own specifications. You don't need to put as much weight on these outlier dates, but it's just something to keep in mind about how you could optimize the way that you choose test and control groups for your types of experiments. So one thing that we love to do at Netflix is put a UI over all of our models. So here is a web app that my team uses to pick test and control groups for different experiments. And so what you see there is a map of the United States and the 7 clusters that all behave somewhat, all the colors represent groups of DMAs that behave similarly in terms of some Netflix metric. So it might be viewing hours, for example. So if you're in that brown, you're kind of all having a similar viewing pattern over time. And viewing, I mean hours that you spend viewing on Netflix. There's also times where you want to think about bleed over. So Seattle and Portland might be really great test and control cities for one another, but if you buy TV in Portland and you're not supposed to buy it in Seattle, they might actually bleed over because of the way that media sort of goes outside the bounds of the city. So we can put in geographic constraints, like, okay, they can't be within 100 miles of one another, which is super helpful. We also do have things in there like the Claritas segments, because maybe not only do we want to look at their time series, but we also want to make sure we have equal representation of like the South or baby boomers or affluent, they call it like technorati or whatever they're called. So we include a lot of different things in here, and it's super helpful for us. And this is Shiny. I don't know if any of you use Shiny. Yeah, okay, so we've done that, and so we have our test and control groups. But it's still not enough because despite our best efforts, they're still going to be different. And so once we run an experiment and we do some sort of intervention, we want to measure the effect, the difference between test and control groups afterwards. And we will have a more precise estimate of that, the more that we're able to adjust for how different they were in the first place. And then again, like I said, clustering is irrelevant for some experiments. Like I can throw the 4 Nordics countries into the algorithm, but what's going to come out? There's only 4 countries. So let me walk you through something that we really did. Of course, I can't tell you what it was, and I have to obscure it, so we'll call it metric of interest. So it's so weird. It's like the CIA or something. So the red line here is Sweden, and the blue line is Norway. And so the x-axis is dates, is time. And so that vertical line, that gray vertical line is when the experiment started. So we did something differently to one country and not the other. That was the intervention. So if you look to the right and you're eyeballing this and you're looking at an Excel and maybe you're smoothing some things out or you're taking a 7-day moving average, it still can be misleading because you might look at it and you might be like, wow, it looks like Sweden is really outperforming Norway. Like, that's awesome. Like, clearly there's something going on here because look at that difference. But then if you look prior to when the experiment started, you'll see that around May 19th, they were tracking very close together, but then they start to diverge. So that started to happen even before the experiment started. So how do we think about that? And I will say that Netflix, we're known for being very data-driven, but 9 months ago, it was eyeballing in Excel. And that's what this, now I'm embarrassed to tell you that, but we're better now. We've reformed ourselves. So what we have done is we're using something called a dynamic linear model, and I'll go into a little bit more detail, but not too much detail about that. And I'm proud to say this is not about big data. Everyone talks about big data. This is not big data. It's one data point per day per region, but we can still get a ton of information out of it. And so we have an aggregated time series by region, we have our controls, and we have a lot of historical data. And again, we can't really eyeball it. So what we want to do is we want to, based on how these regions have behaved historically, we want to use that to make a prediction of how they should behave into the future. And if how they actually behave deviates from how they should have behaved, we know then that because that experiment actually caused them to behave a little bit differently. So let me walk through that. So here's Sweden and Norway. We haven't manipulated them. We haven't done any experiment. They're just like moving along. There's their random drift and their seasonality. And then we start an experiment. We've used the pre-experiment data to predict where they should be after the experiment. After the experiment, we see where the control is. Well, then we know where we think the test should be. The test should be here. The test region should be here, because that's what we predicted it to do. But in reality, it's here. So if the red line at the bottom deviates from the dotted line enough beyond what we expected because of random variation, then we know we caused that, just like we directionally know we caused that, just like we infer from an A/B test. And we can, conclude that this experiment had some sort of effect, some sort of causal effect. I will not linger on the slide. So this is a state space model and sort of a structural model. And really what we're trying to do here is we're trying to take a time trend and we're trying to break it apart. We're trying to separate, random change and seasonal change from real change because of the experiment. So we built this model. Some of the attributes, like I said before, it's really 3 pieces. One is a random walk. And a random walk is just we let these regions sort of drift over time, and they can sort of drift together, or sometimes they drift apart. Then there's the seasonal component, which is the day-to-day variation. And we remove that, because that makes those regions look super correlated when they might not actually be. And then the third piece is a regression. And this is the most important piece, because this is where we include a 0 or 1 indicator variable into our model that says this is when the experiment started in this region. And if that is significant, statistically significant, then we know that the experiment had an effect. So that's our statistical test. So this is what we provide the business. We don't give them the raw data. We don't give them like the crazy mathematical formulas. We give them this. And so here we have the test effect plotted over time. So the black line is the difference between Sweden and Norway. The gray shading are the upper and lower bounds. And the red line represents 0. So you can see that in the first, and I should say all of this time is during the test, is after the test. There's no pre-test data represented here. So what we can see from this is within the first couple days, 0 is not contained within the bounds, so we know that there was a real effect there. And then it disappeared over a couple days. And this is a real example from something we did in that country. Some people were happy, some people were not so happy. So it's great to build a model, but then what if your model is just terrible and giving you misleading results? So we wanted to validate the model and hold it to the same standard that we would hold our A/B test to, which is what's our false alarm rate? Like what's the probability that we're going to say there was an effect when there wasn't? And with A/B tests, it's typically 5%. You're okay with being wrong 5% of the time. And then you also want to know how sensitive is the test? Like how likely is it to detect an effect of a given size? You want it to be able to pick up effects when there is one. So what we found is our model worked pretty well. And so on the left side, our false alarm rate was 0.03. Really, that's conservative because we're okay with 0.05. We're okay with 5%. And then in terms of effect size, you can see on the right side, we were able to detect, let's call it a medium size effect. You're never going to be able to find something teeny tiny, so don't waste your time setting up an experiment where you're like, okay, is a red logo going to work better in Sweden than a yellow logo in Norway? Like that's probably such a minute thing that people are not going to react strongly enough to be able to detect that effect. So when we first started this, our CEO was like, oh, you're only going to find big stuff. Just like turn stuff off, just be super disruptive. You're only going to be able to find big things anyway. But we've proven that we're able to find medium effects. And our next step is to be able to make the models sophisticated enough to find smaller effects. And of course, medium small is completely subjective. It's just our own definition of it. So, there's a lot more work to do. We want to improve the model. We want to add more data into it, like weather. So Weather Underground, I don't know if you know, is like a treasure in that for not very much money, you can get so much historical city-level weather data. So if you're doing any sort of, everyone's like writing this down. If you're doing something that, an experiment or some sort of model where weather can play a factor, we were like, oh, is it going to be like $50,000 a month? I mean, it was like $600 a month. It's like a Silicon Valley company's like sweatshirt budget for the month. So it's super, super inexpensive. And also economic trends, all that data is available usually from government websites or the World Bank. And then we're going to make an R package that everyone will be able to use. I will say a bummer for the nerds that work at Netflix is that we were super excited about our methodology. There was nothing like it that existed that we could find. Most people were doing pre-post when they were analyzing these types of experiments, which was like averaging before and after. That was kind of like what people did, and so we found that to be unreliable. We built this model, we were gonna do a paper, we were like super excited, and then Google beat us to it, and they came up with one, and it's actually good. And it's called, they have an R package too, and it's called causal impact, so you could like go to work on Friday and do this type of analysis, causal impact. They have nice plots. Ours is different from theirs. There's some things that I think that we do better, and so we'll have something on our tech blog and a paper maybe at AdKDD or some other forum that you guys could check out about what we do. I'd say our approach to Google is more similar than it is different, but it is somewhat different. So I brought this up. I know this isn't like a super lofty presentation of like the power of data, but I always like to go to these conferences and pick one like very specific thing that I can take back, and I hope that, you know, most of you in this room can find a use for this. And I want to mention also, there's also this notion of a natural experiment, which is, well, I did something anyway in one country and not another. I didn't like mean to do it that way, but after the fact, you can still use these same type of techniques to try to infer causality from it. So it's called a natural experiment. So it's something to think about. Like, you might already be doing this anyway and you don't even know it. So for those of Arrested Development fans, that image is going to make sense. For us of you, it's not. But I don't know if anyone has any questions. Yeah.
I'm curious about, so whenever the second season of House of Cards came out,
Yeah.
there was a big snowstorm in the Northeast, and people were like really pushing hard for you guys to release that. And you talked about you don't include weather data, right? Like in your, so how are you able to, like for the Squeeze Norway example, how are you able to exclude like potential like massive snowstorm from people indoors versus not?
Yeah, so we haven't up until now been able to do that because we haven't had that great weather underground data, but that's what we're going to start doing. And it is a risk because we're doing one in the US now squarely over the holidays, and we had to make sure there was one extreme weather, winter weather city in each of the groups so that, you know, it wouldn't be like, okay, one group has Minneapolis and the other one has Miami. So you have to kind of do that in your design and then use the weather data to adjust for it. But I think it's better to do it in your experimental design because there's less of an, you know, the more stuff you add to the model and, you know, adds more uncertainty and things like that.
Is that not thinking totally through it and experiment that? Potentially.
If you had done nothing to prepare for it or you have no way to adjust for it, yeah. Yeah, I think so. Yeah. Yes.
How did you close to the time series for shape?
Sparse k-means. Yeah. What's that?
Sorry, on what features?
Just the time series itself. Yeah. We actually don't even like doing that anymore. We do the other one. Yeah, just a little inside tip. Yeah, yeah. Because that one, you start with all of them, and then it builds and pairs and triples, and then you can have more flexibility to.
But sorry, the measure is the residual too?
For k-sparse or for hierarchical, it's just whatever distance metric you want to use. So like the Euclidean distance, or yeah.
More questions for Kelly.
Yeah. Oh. I'm taking over the who gets to answer the question. Sorry. Yeah. Luckily at Netflix, we never struggle to explain to people why they want to know something. People are so hungry for that. But I think small effects. I mean, I think I don't have a good answer to your question. We still, just from a business point of view, those are not super high priority right now, the small effects, because there's still so many big questions we have to tackle. Also, you can't say ahead of time if it's going to be small, big, or medium. I think the most important thing is what do you want to learn and be open-minded to the fact that it might be a 0 to huge effect. So I think that's the right way to think about it. I think if you go in saying, oh, okay, we only care about big effects, well, you're only going to test things that you already think are going to have a big effect, and then you're sort of asymmetric in the things you test. So I think that it's more important to start with what you want to learn. Like we have like several very burning questions, like the online video versus TV one is one, and I don't know, is that going to be nothing? I mean, we haven't done that, but is it going to be nothing? Is it going to be huge? I mean, we don't know, that's why we test. So people are pretty open-minded to that. It was more trusting the results, and I think our team shares presentations like that with our validation for them to trust the results. Yeah.
Was there some analytics done a couple of years back when you guys made the subscription? Seriously, I know it's
In 2011? Yeah. I joined 3 weeks before that, and I was like, oh. No. There wasn't. That was one of our things that we didn't analyze. It's hard to analyze prices because no one wants to pay more. But for the latest price change, we didn't change our prices, but we offered tiers. We did do a lot of analytics around that, and that's probably because of what we learned in that prior experience. So I won't say there was none, but I don't think that was as heavy-duty a data effort as for future iterations of it. Yeah.
So, just to clarify my question, when you're predicting what you anticipate, whatever the KPI is going to be, and where it's going to be, and the chart shows the top and the bottom, do I understand correctly that you're basically just using that one variable, sort of the control market, to make that prediction, independent variable, or about an independent variable?
So yeah, I mean, it's just using that outcome metric. So it's the time series, but it's using maybe like a year or 2 years worth of history of how those two regions have behaved to predict how they'll behave in the future. So it really depends on, like some of our regions, we haven't been there that long, so we don't have as much data. So it's, you know, maybe not as precise, but yeah, it's just that. But you can add other stuff into it, which is why we're talking about weather and economic trends. And then, well, it's that plus the 0-1 indicator for when the experiment starts. Yeah.
I'm going to ask one. Did I hear you say that planning at Netflix was scanning spreadsheets 9 months ago, and that what you're talking about here is?
I'm going to get in trouble for saying that. So I would say, you know, Netflix is super rigorous in all ways, and quasi-experimentation is like the latest frontier. And we would do these in the past, and we would kind of eyeball them. And then my team stepped in and came up with this model. And I would say it was the outlier because in all other areas, we are extremely data-driven and doing the most advanced things. Yeah, in my opinion, I mean, I think we're doing some of the most advanced things. Yeah. Yeah, please don't leave this with your takeaway that Netflix uses Excel for its predictive analytics. That was not right. Yeah.
Hi, so you mentioned your components of the stochastic model. So you have your random walk, you have your experiment, and then you have this seasonality. But besides traditional seasonality, I was wondering how the non-traditional, non-broadcast flighting of Netflix would affect your seasonal variable. So really, how are you differentiating between an experimental variable into something that now becomes a sort of seasonal, continuous variable?
So I think I get what you're saying. Let me try to answer it, and then you tell me if I'm not saying it. So the one weird thing about this is what is a false positive, right? Because we could have done something super weird, or Norway just really liked House of Cards more than Sweden 6 months ago. But that's not, or they do that once the experiment starts, and it's not a false positive. So I think that's the art and the science part of it. I mean, you can build in indicators for that kind of thing, like, oh, orange is the new black, launch during the time of this experiment, but that's a hard question, and that's something that we have to deal with. And I should mention the validation is on simulated data, it's synthetic data. So we can insert some things into it, but it's not actually like our real, I mean, it's it's synthetic, so yeah. But it actually has not been as big a problem as we thought, yeah.
More questions? Okay.
Yeah, so I'm still trying to get a good understanding of when this would be applicable. Google says their causal impact packages, they mainly use it to measure the impact of AdWords campaigns on sales. And I guess I would think that that would be a case where you could do a strict A/B test. So is this when you can't use a strict A/B test, or is this instead of? Is this better than A/B test?
If you can do an A/B test, do an A/B test. This is when you can't do an A/B test. Yeah, for sure. I mean, and it's also, yeah, and a lot of those problems are in marketing, quite frankly, because you don't have control over the things that are happening. I mean, you can ask MEC. I mean, MEC can't, they can't randomly assign people to see different television commercials. So, doing this is your option.
So you were careful to thread the distinction of causality. And I wonder if you would agree, though, that perhaps Google went over the line a little bit in some of their press about the causal impact package.
Well, I haven't been like, oh, there's people from Google here. I haven't been part of like the press. I just know that we've used it and we've compared it to our results and we've gotten the same answer. I don't know how they're marketing it, but we've been happy. I mean, our thing can do different things and in some ways it's more flexible, but we feel good about theirs. Like we're using it.
You were careful not to make any strict causality claims.
I don't think you can make strict causality claims with any of these things. I mean, I think it's more that directional piece of it. Yeah, but I wouldn't say like we're saying it's not at all causal. I mean, that's the whole point of this is we want to feel some confidence that there's some causal mechanism here. Yeah, but I didn't know there was like a ton of like press or whatever. Yeah.
All right. Any other questions?
So there's, I don't know, I'm not very familiar with the sort of area of research on causality. There's several things that you can use to get more confidence causality. One of them is like, dosing, other things. Have you thought about conducting the quasi-experiments differently to get more signal?
Yeah, that's a really great question. I mean, another way to make it more powerful is an on-off. The more zeros and ones, that linear regression is the zeros and ones. So you can have 1 0 or 1, which is one country versus another, or you can have people switching on and off. So we've actually done that as well, where we've had 2 countries alternating on and off, and that adds even more power. It's just, again, at the end of the day, these people, like these poor marketing people were like, can you please like design your campaign? And they're pretty good about, they're pretty awesome about it, but you can't like, you have to like draw the line somewhere. But we have done that, and that's a good point. So yeah, you add more power the more alternate, time periods and zeros and ones. Yeah, and even if you have 6 cities, like we were going to do something. We went to our CMO. We're like, okay, we have 6 cities. They're all going to be on and off at different times. They're going to alternate like 10 times over the next 6 months. He was like, no, and you cannot do that. But we compromised and we landed with a pretty good design. So yeah.
Any more questions for Kelly? Wow, well, let's thank Kelly for a great talk.